All right, ladies and gentlemen, welcome back for another round. We're going to wrap up bonding today. This is Mr. Doolin. Thank you for tuning in. And today we're going to take a look at metallic bonding. So previous to this, we've actually looked at covalent bonding and properties of covalent bonds, ionic bonding and properties of ionic bonds. And then today we're going to finish this up with metallic bonding. And the first thing I want to get out of the way is that metals actually do not bond with other metals. All right? And then you ask yourself, but wait a minute, Mr. Dillon, we're talking about metallic bonding here. And now you're telling me that a metal will not bond to another metal. This is true. There is no bonding per se. There are general attractions to electrons. And what I mean by this is I'm actually going to go ahead and draw a picture of aluminum. And I'm going to give myself my 3 ions here, so 3 plus. And so I'm writing 3 plus because aluminum forms a 3 plus ion. It's got 3 valence electrons. And then I'm going to use red here to actually draw the valence electrons. And so if I've got 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so each of those aluminum atoms will release their valence electrons into this pool of electrons, if you will. And so what we end up with is in this particular situation, we end up with positive ions in a sea of electrons. All right, and so the positive ions, and that's what happens with metallic bonding, is that the metals actually will just release their valence electrons into this shared pool such that they're free to move around the metal. So the electrons are free to move wherever they want. All right, now if I'm looking at, say, particularly these two aluminum atoms, they have a general attraction to all of the electrons around. Now what holds a metal together is that you do have attractions of these aluminum ions to the same electrons. And so it's essentially, they're held in place where they're at because they're both attracted to the same thing. Now it's not a directional bond, all right, because they're also attracted to the electrons on the other side. But there's a couple of statements that I'm going to go ahead and pause and I'm going to write over here on the right-hand side that describe this general property. Okay, and so the 2 statements I've got there is that metals release valence electrons into a shared pool of electrons such that the electrons are free to move around the metal. So all of these electrons, they're in motion. They've got kinetic energy. They're going wherever they want to go. The positive ions left behind have general attractions to all electrons around them, and that's what's holding the metal together. And so you have to understand the next statement. My melting point of my metal is dependent on the number of valence electrons released, right? And the size of the positive ions as well. All right, and so that should make sense, right? Because remember, everything's all about magnets. We understand that if I get a greater number of electrons released, I've got a larger positive magnet right there, and so my attraction to these electrons is a lot stronger, right? And if I'm holding myself in place because of that, in order to melt the metal, I've got to overcome that attraction between the metal and its electrons. I've got to spread them out. All right, and so there are 2 other properties of metals that we're going to take a look at today. The first one is conductivity. So the first one's conductivity, and the other one is workability. All right, and so let's take a look at conductivity. The conductivity has to do with the properties of the metals, and this can be either electrical conductivity, or it can be thermal conductivity. So the ability to conduct electricities, or the ability to actually conduct heat, has to do with the conductivity, and it's all dependent on the free electrons, that sea of electrons. And so that's definitely something you want to get down here is it's because both of these, the property of conductivity for metals is because and happens because the metals lose those valence electrons. They release them into that sea of electrons. And it's actually the electrons moving that allows the conductivity to occur, right? Electricity should make sense because electricity is just electrons moving from one place to another, right? So if your electrons are already free to move, it makes sense that they should be able to conduct electricity. And then the thermal conductivity occurs because remember the old statement that we've gotten to so far is that heat them up, speed them up. It should make sense since my electrons are already free to move around, I can get more kinetic energy in there. It's easier to make them move faster, all right? So my workability, this has to do with the property because of those positive ions are there and there's no directional attraction or bond, is that I can actually just shove them around. I can physically push these around. Now, the two words that you'll want to be familiar with is ductility and malleability. All right, ductility is the ability for me to draw these metals into a wire shape, and malleability is my ability to actually work it, to beat it into a flat sheet, right? And so it should make sense if I'm going back up here on my drawing that if I wanted to, if I was looking at this one, I could physically, with force, push it in between the other ions, all right? And that has to do with workability. So where conductivity was based on the electrons, workability is based on the fact that those positive ions, I can actually push them and slide them between and by each other because there's no directional bond there, all right? And so that is what you actually want to get down here, is that workability exists because of the positive ions. There's no directional bonding there. It's just a general attraction of the electrons that are there, so I can actually push them around physically, all right? Okay, so that actually gets us all the way through all of our bonding, and you should know by this point all the characteristics of the bonding. If you had any questions over this, make sure you get them down. I'll see you in tutorials. We'll get that taken care of. Otherwise, I will see you in class.